Today, we're going to be talking about LangChain Expression Language, which is a pretty interesting idea that essentially allows us to write very minimalist code to build chains within LangChain. And for sure, I think we'll see from this video, we can use a lot of LangChain's more advanced features like parallel execution, async, and streaming very easily using the expression language rather than just the more typical approach to building LangChain chains. And in my opinion, it's worth trying just for that. I think we'll see that just using this, you can build stuff very quickly. That's not to say it doesn't have its cons, but we'll dive into those later. So let's just begin with what this expression language actually is. So there's a page here in the LangChain docs talking about this expression language, right? So it's LCEL for short. And yeah, they just explain a few things, you know, streaming, async, parallel execution, so on and so on, right? But let's just jump into this notebook and we'll see more of how this actually works. So there will be a link to this notebook, as there usually is, at the top of the video right now. And I've written all of this in Colab, so you can do the same. It's pretty straightforward. We have a few prerequisites. We're going to be using LangChain, of course. We're going to be using Anthropic, the new Claude 2.1 model for our LLM. We're going to be using Cohere for the embeddings. And we're going to be using a Docker array just so I can give you an example of parallel retrieval later on, which is super interesting. Now, the main things that I think we would want to use the expression language for is these three items here. So we have superfast development of chains. We have those advanced features. Streaming, async, parallel execution just work out of the box with these super fast and easy to set up. And there's also easy integration with the other LangChain products, so LangSmith and LangServe if you are using those. Now, let's take a look at what it actually looks like. So to get started with this, we're going to need a Anthropic API key, and you can get that by going to console.anthropic.com. You'd come into here, hopefully you have an account already, and you can click Get API Keys, and you're just going to get your API keys from there. If you don't have an Anthropic account, I think there's still a very minor wait list. So one, I just recommend you sign up and you'll get access pretty soon. But so that you're not waiting, you can also just use OpenAI. So you would just swap Chat Anthropic here with Chat OpenAI and swap Anthropic API key for OpenAI API key. And if you do that, you will also want to drop these two arguments. It'll make things easier. So looking at this, let's see. We'll put our API key in here. And once we have that, we now have these three components. We have a prompt, a model, which is a chat model, and a output parser. Okay. Now in typical LangChain, we would chain these together using the LLM chain. Okay. So you can see LLM chain, or your prompt, the LLM, and the output parser. Okay. What I'm going to do is take this prompt where we're asking to give me a small report about a particular topic. Okay, so the input to that is going to be topic, and you can see that here. So we have topic, artificial intelligence, and it's obviously just going to output a small report on that. Okay, so let's run that and see what we get. So it's running, we create our chain, running chain.run. And we'll just print the output, and we'll get this small report thing on AI. Okay, so all looks pretty good. Now, how would we do that with the expression language? Well, we use this pipe operator, and I'm going to go into detail as to how this actually functions, because I think that's understanding how this pipe operator functions allows us to just understand what is actually happening here. Okay, so that we can actually understand this abstraction rather than just blindly using it. So we string things together, right? So we have our prompt followed by the model, followed by our output parser. And rather than putting them into an LLM chain or some other chain, we just string them together with this pipe operator. So, I mean, it's like, for sure, if I look at this, it's simpler than this, right? If you compare those two. It's, I would say, also more flexible because we can just string things together. But it's, I think it's not so Pythonic as to what we're used to. Whether or not that is a good or bad thing, I'm undecided on. Like, I like the minimalist approach here. It looks great, but it's maybe hard to understand. Like, if you don't understand the syntax and you understand Python very well, this can be pretty confusing. But anyway, let's run that. So we create our chain using this expression language syntax. And then we just, rather than running run, we run invoke, and we pass a dictionary of input variables into there. So we run this, and yeah, it's going to do the exact same thing or very similar output to what we saw before. Okay, so it gives us this little report again. Okay, looks cool. So these two things, this and this, doing the exact same thing, just different syntax. Now, I think when you see that syntax with the pipe operator for the first time, at least for me, I was quite confused, and I think most people would be confused. The way that it works is pretty simple. At least the idea behind how it works can be explained very easily. What we see on the left of each pipe operator, the output from that gets passed to what is on the right of the pipe operator. Okay, and then the output from this is passed into this. So it's literally piping things from the left of the pipe operators all the way through to the right of the pipe operators. That's all it's really doing. Now, how that pipe operator actually works is more, not necessarily complicated. It's probably a little bit hacky in my opinion, but it's kind of interesting. So this pipe operator, when we apply it to an object in Python, what it actually looks for within that object is this OR method here, right? So if I come down to here, we have this kind of confusing class called Runnable, but let's break it down a little bit. Okay, so I'm going to do class, and we're still going to call it Runnable. Now, when we initialize this class, we run, obviously, the init method here. And within that, we're going to pass a function, right? Because the way that we're going to implement this is we're going to give a function into this class, and we're going to use this class to transform this function into something that we can use this pipe operator on. So we want to save that function within our runnable class or object. And then the next thing you see, this is the part that makes the pipe operator work. Okay, so when a pipe operator is applied to it, an object, it's going to look for the object's OR method. Now, the OR method, that needs to contain another function that we call other here. Now, the way that you can think of this, the func and the other arguments here, is that func is kind of what is on the left of our pipe, and other is what is on the right of our pipe. Okay, so what we do is we create this chain function here, which is going to consume a set of arguments and keyword arguments. So we can call it chained func, as we do there. We have our arguments, and we have our keyword arguments. Now, the reason that we set up with args and keyword arguments like this is because we don't know the names of the parameters that are going to be input into our function, right? So by doing this, we can, those parameter names can vary. We can have more or less, and this chained function will be able to handle those. So we would do return other, so our basically this function here that consumes the output from our function. Okay, and again, that function is going to take those args and keyword arguments. Okay, so from that we would then return the runnable here. So this is going to be our runnable version of that chained function. So basically, by doing that, we're putting this ability to run chains within each one of the functions that we pass through this actual chain. Okay, so we can do multiple of these. So we could have, other 2, other 3, so on and so on. Now, the final thing that we need to have here is a method that allows us to call and begin this chain. Now, I'm going to implement it with this. We will see that LangChain actually uses, I think they use invoke. So rather than call, they would have invoke here, and that starts the chain. But I'm just going to do call because I think it's simpler. So that is our runnable function. We can run that. And I also have it here. Maybe I'll just run this one. And what we want to do is use this runnable to kind of wrap around different functions that we would like to run with this pipe operator approach. To do that, we're going to define 2 very simple functions here. One is add 5, one is multiply by 2. Okay, so let's run those. And I'm going to wrap those with this runnable object that we've created. And then using this approach, right? So we have the chain. We're going to do add 5, and then rather than using the pipe operator, I'm going to use the OR method directly. And then within that OR method, I'm going to pass our multiply by 2 runnable. Okay, so we have those, and then we can just call our chain. So we pass 3 to it, and we get the value 16, which is, that's correct. So we do 3 plus 5, take both of those, gives us 8, and multiply those by 2. Okay, so it's correct. It's run in the correct order. Now we can use this syntax, or now that we use this OR method, we can also use the syntax that we see here with the pipe operator. So let's try that. Okay, and you can see that we now have this. So yeah, that's pretty interesting. So we can build our own pipe operator functions using this. And this is what LangChain is doing. Okay, so when we see this LangChain expression language, this is what we're actually looking at, which is an interesting way of putting things together. Now, that's how it works. Let's have a look at how we actually use the expression language itself. So we saw already, we can use the OR operators or the pipe operators. Now let's put it together in an actual use case. So I'm going to be using the Cohere embedding model. You can also use OpenAI's embedding model. It's up to you. But to get that API key, I don't think there's a waitlist for Cohere, so you should be able to jump straight into it. You can go to dashboard.cohere.com. You'd go to API keys, and from the API keys page, you can create either a trial key or a production key, and you just use that. So I'm going to add mine in here, and I'm going to be using the Cohere embedding model. So the newest one from now, which is very high performance embedding model. I'm going to be using that to create 2 kind of like document stores that we have here. Okay, so we have, they're very small. It's just for an example. We have one where we have half the information in vector store or document store A, and half the information in vector store or doc store B. You'll see why soon, but for now, what we're going to do is just use the first one. Okay, so we're going to use A. Right, so it contains information about me when my birthday is. The other one contains the year of my birthday. So let's try putting information into the vector store, or retrieving information from our vector store, and then feeding that alongside the original query into a chain using the expression language. Now, when we do this, there's one important thing that we need to be aware of, which is when we use this syntax, just using this syntax and nothing else, we have like one input and one output to each of these items, right? Each of these components. So how does that work when we have, we have a context that we need to use here, and also a question that we need to feed into our prompt. And the way that we do that is by using this RunnableParallel object. So I've imported those here. We have RunnableParallel and RunnablePassthrough. The RunnableParallel, which we have here first, it allows us to run multiple chains or components in parallel and also extract multiple values from them, right? So here we're going to run retriever A, and then for this question, we're using this RunnablePassthrough item. What RunnablePassthrough does is whatever was input into the retrieval or the RunnableParallel object, it's just going to return that, okay? So it's literally a pass through for values that you pass into here. So let's run all of that, okay? So we have our retriever A here that we're using. We have our prompt template, so on and so on. Right, we have our retrieval that happens first. So we have a query, when was I born? We're going to invoke that. And this value is being passed into our retriever. It's doing a search, getting the context. It's also being passed to here and going straight through to our prompt. Okay, so then our prompt gets formatted. With the question, we have when was James born? With the context, we have the record. We will have the records from here. Okay, some vector A. So my birthday, the actual date. Now what we will get here is, unfortunately, I do not have enough context to definitively state when James was born. And it tells me what it found. It found this little bit of information. So it knows that my birthday is then, but it does not specify the year that I was born. Okay. So it can't actually fully answer the question, but we can see that this chain is working. It's going to the retrieval component, it's doing our prompt, model, output parser, whatever else. It's going through everything. Now, the cool thing with RunnableParallel, as you might have guessed with what we have here, is that it can run many things in parallel, not just a retriever and passing through a question. We can actually run multiple retrievers in parallel, or we can run multiple different components in parallel at the same time. And this is one of the things that is very cool about the expression language, is that it, we set these things up in parallel, and like RunnableParallel here is just going to do them in parallel, right? It's going to run those in parallel. We don't have to deal with building or writing any of that code ourselves, which is, I think, pretty cool. So let's come down to here. What I'm going to do is, now that we're going to be retrieving information from two places, I'm going to create a context A and a context B. We're going to run that, or we're going to initialize the prompt. Then our RunnableParallel, now we need to modify it a little bit. We need to add, so we have retriever A, we're now mapping that to context A, and we have retriever B, which we're going to map over to context B. And then as before, we have our question, which is the RunnablePassthrough. Now, the chain itself is exactly the same. We still just have one retrieval component there. Now, because both our retrievers are being run in parallel within that abstraction. So we're going to run that. And now I'm going to say the same question. When was I born? Okay, so now it knows. Based on the context provided, James was born in 1994. Okay, it's stated in the second document, the page content, James was born in 1994. And maybe if I want to kind of say, okay, give me the date as well, I'd say, what date exactly was James born? And we actually get this, which is odd because, so it says, unfortunately, the given context does not provide definitive information to answer the question, what date exactly was James born? But then it gives it us here. So we have, I don't know, there's a little bit of a lack of reasoning ability with Claude in this case, clearly. So my birthday is 7th of December and I was born in 1994. I don't know why. It's kind of surprising to me that it didn't get that, but interesting. But at least we can see that our chain is working correctly. We can see that it's pulling in information from both our retrievers there, which is cool. And we're almost done with what I think are the essentials of the expression language. There's just one more thing that I think is super important, and it's basically LangChain's abstraction of doing what I showed you earlier, where we created our own sort of runnable class and fed functions into it to create these things that we can run with the pipe operator. So to do that in LangChain, they have these runnable lambdas. Okay, and this is why earlier on I called that class a runnable, because here they call them runnable lambdas. So we have our add5 and our multiply by 2. I'm going to just come up here and show you what we had earlier. So yeah, we have these two functions. Let's take those. Okay, we can see a runnable. That's what we were doing before, so that we could use this. Let's do it again here. All right, so we have our add5 and our multiply by 2. Let's run this. This time we're doing runnables, but we're just doing them through LangChain. So our chain is going to be add5 multiplied by 2 as we did before. And as I mentioned, LangChain, we have to use invoke rather than just calling the object directly. So we run that, and yes, as before, we get 16. So yeah, we can wrap our own functions using LangChain's RunnableLambda here. Now, when would we use that? I mean, there are definitely different scenarios where we might want to use that, but let me just show you something here which kind of bothers me a little bit, and it's a good example of where we might want to use this. Either use this, or we probably want to adjust the output parser as well. So we have, let's run both of these. What we see when we run this is, one, there's some like leading white space here that we could do with removing, but it also starts each answer with this. Here's a short fact about artificial intelligence, and then we have 2 double new line characters. Maybe I don't want that, and I just want it to get straight to the fact. So what I can do is use this RunnableLambda abstraction to do that, right? So I'm going to define a function which is going to look within this string for a double new line within the string. If that is in there, we're going to split by double new lines, and we're going to take everything that occurs after the double new lines. Now, in the case that maybe there are multiple double new lines, we're taking everything, one from one to the end of the list that we would get from this, and then we're joining everything back here. Okay, so we're basically just dropping that first one, the first part here. So let's run that. I'm going to wrap that within a RunnableLambda, and then I'm going to put all of those things together, and I'm going to add the get fact runnable to the end of my chain. Now let's invoke again and see what we get. Okay, so there's no weird starting text here, and we see with both of those it works. So our little RunnableLambda here worked well. Okay, so that is really everything I wanted to cover with the expression language. I think there's other things that we can talk about and more to cover, but this is, I think, pretty much everything you need to really get started with it and just understand what this abstraction is actually doing, which, like I said at the start, it's important to understand, because then at least we know what we're doing rather than just kind of putting in these pipe operators and kind of thinking they should work when maybe we're doing something that doesn't make sense. So I hope this has been useful for understanding the expression language. There's pros and there's cons to using this. Now, on the pros, obviously there's the minimalist style of the code, which is kind of nice. It's very clean, and the out of the box support for different features like streaming and the parallel execution that we saw. But there are also some cons, and there's plenty of people that are less fond of the expression language, as it's a big change. It's to be expected. Now, the things that people point to when they're like, this doesn't make sense, is that it makes things more abstract. LangChain is it's abstractions already, so we're kind of adding another abstraction to the abstractions. And that the syntax it's definitely not common syntax for Python. And that kind of goes against the zen of Python, which is that we kind of shouldn't make special cases for things. And of course, it's a new syntax. It's, especially when you first look at it, I think once you've explored it a little bit, it makes sense. But when you first get started with it, it's definitely confusing. So in my honest opinion, I think both of those viewpoints are entirely valid. There's pros and cons for sure, but I like it. I think it's definitely worth learning and experimenting with, and it can definitely speed things up particularly when you're prototyping, and maybe in production code. It's going to depend on what you're wanting to do there. Anyway, that's it for this video. I hope all this has been useful in understanding the expression language. So thank you very much for watching, and I will see you again in the next one. Bye.